Okay now, good morning guys, you are welcome to today's episode. Today we will be discussing one of the most fundamental theory in chemistry. And as you know, we know John Dalton is the father of chemistry. He has laid a very fundamental theory in chemistry and called the John Dalton atomic theory. John Dalton atomic theory is states in strata. So we'll be starting with the first one. The first John Dalton atomic theory is that all particles are made up of atoms. All matter, like any types of matter you see, is what made up of atom. Now, that theory, what the theory is saying is this: any object at all, any object you could think of at all, is not made up of any other thing. Anything you can feel or touch is made up of one particular substance called an atom. That was the first postulate. Then we go further to see what is atom. Now, the second theory is atom can neither be created nor destroyed. Now, we have first known that every substance is made up of atom, and then we said, what is the nature of the atom? John Dalton now said atoms are made up of atoms can neither be created nor destroyed. That is to say, they already exist. Something like hydrogen, sulfur, chlorine, every element you know, your iron, your cobalt, your vanadium, all the elements, they exist. That was the second postulate. You understand? Then his next theory is all chemical reaction comes from what? The combination or separation of atom. That is to say, any happening within our environment which is terms a chemical reaction, like the burning of fuel. The burning of fuel is has to do with what? Separation of the hydrogen that is connected with the carbon in the alkane chain to give us carbon dioxide and water as our product. The burning of your charcoal at home that you know is a combination of oxygen with carbon. Charcoal is an amorphous carbon, is a carbon, to give us what? Carbon dioxide. You understand? And then heat. So that was this third theory, that all chemical reactions result from what? The combination or separation of what? Atom. Now, the next theory is this. He said when atoms combine, they do so in simple whole number ratio. That is to say, atom doesn't combine randomly. Like a specific number of atoms combine with another specific number of atoms to give us a compound. But another thing to note there is say in simple whole number ratio. It means the number of atoms that combines with another number is a very simple whole number ratio. Simple whole number ratio is not something very big. Like one atom of oxygen combined with two atoms of hydrogen to give us water. One atom of oxygen combined with one atom of carbon to give us carbon monoxide, or what you call carbon dioxide. And then two atoms of oxygen combined with one atom of carbon to give us what we call carbon dioxide or carbon dioxide. Then now the last theory is this. He said atoms of the same element are alike in every aspect and differ from atoms of every other element. That is to say, if you look at an iron has its own property, and that property is make it different from every other element. Now, if you look at carbon, that reddish copper, that reddish brown copper is the metal in your wire, like your home used wire. You understand? That reddish brownish color is what? Is the property of what? Of copper. Now, if you look at your aluminium, the overall cable that you see on the street is an aluminium listing, is aluminium metal. So they are different. If you look at gold, the color of gold, the shiny nature of gold is different. That's what John Dalton is saying here. As good as the theory it has given us a strong base in chemistry, telling us that every substance is made up of atoms. So when you go close to any substance, you know it has an atom. Then you already know that this atom you cannot break this atom. Do you understand? Then so looking at the theory, they are as good as they are. They meet with every surrounding theory as of that time. But as time goes on, some improvement needs to be made as some discovery comes up. So we'll be discussing the modification of John Dalton atomic theory. So which of the theory was first modified? The first theory that was first modified is this. He said atom can neither be created nor destroyed. Now, when radioactivity was discovered, people noticed that, as you know, radioactivity is the spontaneous disintegration of the nucleus of an atom to give us other atoms with the combination of alpha particle, beta particle, and gamma ray. Now, during this radioactivity, an atom of big element like uranium will break into 2 or 3 to give us atoms of smaller element. So that discovery now countered the first idea of John Dalton that atom cannot be created nor destroyed. Because during radioactivity, uranium atom was destroyed to form other element and give us other particles. So the theory has to be modified. It was modified too. So atom is every substance is made up of atom. The first one is acceptable, but the second one is no longer acceptable because of what? Radioactivity. Now, another modification again is said, when atoms combine during chemical reaction, they do so in simple whole number ratio. That theory is acceptable because as of that time, it was in 18 something that he proposed the theory, 1818 or 1814. Now, that theory could hold at that time because the compound present as of that time, all these chlorine gas, and the rest, all these chlorine gas, ethane, methane, ammonia, having 1 atom of hydrogen, having 1 atom of nitrogen and 3 atoms of hydrogen. Our water having 2 atoms of hydrogen, 1 atom of oxygen. Our sulfur are having 1 atom of sulfur, 2 atoms of oxygen. Those combinations, those compounds, as of that time, they were minimum combination, like it is in a very simple whole number ratio you get. But as time goes on, people discover what we call giant molecule. Giant molecule like all these protein. Protein has over 1,000 of carbon atom and more than 2,000 of hydrogen atom inside. You understand? So the combination is not in a simple whole number ratio at all. You get. So that theory has to be modified with the discovery of a giant molecule. Something like carbohydrate, something like protein. In fact, human being is a giant molecule on its own. Every skin you see within your body has to do with combination of one atom with the other one. You understand? So that theory has to rest with the discovery of what? All these giant molecules. Now, the next theory that was modified is this. He said atoms are alike in every aspect and differ from atoms of every other element. Yes. As of that time, there was nothing like oscilloscope. Oscilloscope is a sophisticated device that is used to measure the mass of an atom. Now, when oscilloscope was discovered and people can now measure the mass of atom to a very precise level, it was now discovered that something like chlorine if you collect some sample of chlorine, you measure, and you are able to measure the mass of the chlorine. Some are giving you 35, 36. Some are giving 37. Is giving different mass. You understand? Something like carbon, you can see carbon 12, and other atom maybe having carbon 13 mass. You understand? So they now notice that he said they are alike in every aspect, but they are now noticing something different. So they have to modify the theory. Atoms of the same element, they are alike actually, but not in every aspect. You understand? One unique thing that you must know about atom of every element is this: atom of every element have the same atomic number. Atomic number is the number of proton in the nucleus of an element. That proton cannot change. It's the same for every other element. But the atomic mass number, which is the combination of the number of proton and the number of neutron, can change, because neutron vary from atom to atom. You get? So that theory has to be modified. So this discovery now bring into science diction what we call isotope. You understand? Isotope has to do with two or more atoms of the same element having the same atomic number but different mass number. You get? So that theory has to be modified. Now, so that will be the end of our video. As good as Jonathan atomic theory, try to understand what he has said, because for some element, for some compound it was, but know the modification, knows that we have gone beyond that. We have something like radioactivity right now, we have isotope right now, and the rest of it. So you are most welcome. With this theory, you now have an overview of the journey into chemistry theory. The other theory we will talk about later. So please, I beg you, like this channel, and if there's any video, any topic at all in chemistry you want me to talk about, please post it and we'll talk about it. Now we don't do much of writing because this is the basics. If there is any calculative stuff you want, let me know, we will do it. You understand? Thank you.